This video will focus on working with area of a sector. Now, before we can work with area of a sector, it's helpful to know exactly what a sector is. I think about a sector like a piece of pie, or maybe even a piece of a round piece of pizza. So another way to explain it might be to think about it like a little wedge. So that shaded part of the circle would be a sector. Remember that when you're finding the area of a whole circle, we use the formula area is equal to pi times r squared. Since a sector of a circle is part of the whole area, we're actually finding a fractional part of the area of the entire circle, and therefore we use ratios. Now, there's three ratios that we're going to be using as we work through these types of problems. All of these ratios is going to compare a part to a whole. And we're going to set up two of these ratios and set them equal to each other such that they'll form a proportion. And we can actually look at any two of three ratios. The three ratios that we're going to consider are the sector area, which is the part of the circle, over the whole area. We might compare that to the measure of a central angle, which is the part of the circle over the whole 360. Or the other ratio that we might consider when we're doing this is arc length, which represents part of the circumference over the whole circumference. So again, we're just going to set up or use any two of those three ratios and set them equal to each other and solve using a proportion. Which two will be determined by the information that we're given in the problem. All right, so speaking of problems, let's go ahead and take a look at how one of these might look. In number one, it says find the area of a sector with a central angle of 60 degrees and a radius of 10. Express your answer to the nearest tenth. All right, so if I scroll back up, I'm looking at here a sector, so I want to use this first ratio, and a central angle. So I'm going to ignore arc length and circumference and instead write a proportion that uses sector area and central angle. So I'm trying to find the area of the sector. I'm going to say let x represent the sector area. And in order to use this first ratio, I need to have the sector area in the whole area. Well, this question now becomes find the area of a circle whose radius is 10. So I know I can find the area of a whole circle by using that formula that you've been using since middle school. I'm going to substitute in the 10 in place of the r. So the area of a whole circle whose radius is 10 is 100 pi square units. So I've got x, the sector area, over the whole area of 100 times pi is equal to the central angle, which they tell me in the problem is equal to 60 degrees, over the whole 360. So again, it's part over the whole is equal to the part of the angle over the whole 360. You can go ahead and cross multiply exactly as it is. I'm going to instead simplify that fraction on the right-hand side to give me numbers that are a little bit more friendly to work with. So I'm going to leave x over 100 pi, but when I simplify that fraction on the right side, I get 1/6. So now cross multiplying 6x is equal to 100 pi. X, my sector area, is going to be equal to 100 pi over 6. They're asking me in this problem to solve that to the nearest tenth. So I'm going to go ahead and dig out my calculator. You're going to go ahead and dig out your calculator too and punch these numbers in as I go along. So I've got a fraction where the numerator is 100 pi and the denominator is 6. And rounded to the nearest tenth, 52.4. So x, my sector area, is about 52.4 square units. Excellent. Let's go ahead and take a look at the next one. In number 2, it says find the area of the shaded sector. They tell us that the radius is 6 inches and the central angle is 100 degrees. Express the answer to the nearest tenth. This one looks very similar in that we're dealing with, again, the area and the central angle. So again, I'm going to say let x be the sector area. So I've got x, my sector area, or my part, over the whole area. So I need to go and I need to find the area of a circle whose radius is 6. So again, I'm going to use that formula from middle school. And if the radius is 6, the area of the whole circle is 36 pi square inches. The part of the circle that I want to consider is the central angle of 100 degrees over the whole 360. So again, I'm going to simplify this fraction just so that I have numbers that are a little bit more friendly to work with. So x over 36 pi on the left, when I simplify that 100 over 360, I'm going to do that simply by punching it into my calculator. So it makes it a little nicer to work with, not a whole lot, but it is a little nicer to work with. So that ends up being the fraction 5 over 18. So 18x, when I cross multiply going the other direction, ends up being 5 times 36. That's 180 times pi then. I'm going to divide both sides by 18. So x ends up being equal to 10 pi. And they want this to the nearest tenth. So I'm going to grab my calculator and I'm going to find 10 pi to the nearest tenth. So 31.4. And that would be square inches, or inches squared, however you want to think about it. Excellent. This next one, a little bit different. It again, like the first couple, is dealing with area, but this time instead of dealing with the central angle now, we're working with arc length. So if I go back to those ratios up at the top, I want to deal with area and arc length this time. So I'm going to approach this very similarly. You might want to draw a picture just because it'll give you a visual representation of what's going on. So we're looking for the area of this sector. I'm going to say again, let x be the sector area. This time our circle has a radius of 12 and our arc length has a length of 40. So that arc length right there is 40. And both of those are measured in centimeters. So I'm still going to use part over whole equals part over whole, but this time I'm going to be comparing the part of the area over the whole area to the part of the circumference, otherwise known as the arc length, over the entire circumference. So like the first couple of examples, I need to know area of this circle. But this time I also need to know circumference. So circumference is either pi times diameter or 2 pi r, however you want to think about it. I like pi times diameter. So the entire circumference of this circle is 24 pi. So my part of my area, x, over the whole area, 144 pi, is equal to my part of my circumference, 40 centimeters, over the whole circumference, 24 pi centimeters. So I'm going to go ahead and I'm going to cross multiply. If I wanted to, I could simplify this fraction, but this is going to get a little ugly no matter how I look at it. So I've got 24 times pi times x equals 40 times 144 times pi. So that's going to be 5760 times pi. To clean things up a little bit, I'm going to divide both sides by pi. So now 24 times x is equal to 5,760. And now I can go ahead and divide everything by 24, and I'll have my answer. So 240 square centimeters. And again, I'm going to remember here what I was looking for. I was looking for area, and that's how I know the dimension or the measurements are going to be in squared units. All right, I do want to take a minute and look at this one up at the top of the next page with you because it's a little bit different. This one talks about circle O. So, and unlike the first one, the last one that we did, there's no picture. So I'm going to go ahead and draw a picture. There's a circle with O as its center. Diameter AB has to pass through circle center O. And that diameter has a length of 15 centimeters, making each radii 7.5. The measure of some angle BAC is 65 degrees. So this angle here is 65 degrees. And if that angle there is 65 degrees, I know that the length of its intercepted arc has to be double that because it's an inscribed angle, making the length of that red arc 130 degrees. So it says find the area of sector BOC and express your answer to the nearest tenth. So that's the sector, or that's the piece that I'm looking for the area of. So I might start out again by saying let X represent sector area. And I can approach this in a couple different ways. I know that if the length of this red arc is 130, then the measure of this central angle has to be equal to that of the arc, or 130. So I'm going to go ahead and I'm going to write, I'm going to use angles, and I'm going to use areas. So part of the area, the sector area, over the whole area, well, now I need to go find the area of a circle whose radius is 7.5. So again, area is pi times r squared, or pi times 7.5 squared. And when I get my calculator out and square 7.5, I find that's 56.25. So the area of the whole circle, 56.25 pi, that's equal to the measure of the central angle, 130, over the entire 360 degrees. So once again, I'm going to go ahead and I'm going to simplify that on my calculator. And when I simplify that, I find that it ends up being 13 out of 36. Cross multiplication will give me 36x is equal to 731.25 pi. When I divide both sides by 36, I end up finding out that to the nearest tenth, I end up with about 63.8. And again, x represents area, so I know that has to be in square centimeters or centimeters squared. All right, no matter which one I use, regardless of whether I use angles, areas, or circumference, I'm always comparing part to the whole in the first ratio and part to the whole in the second ratio. there's one thing that's important to remember about this video. That's probably it right there. But I'm going to let you go ahead and summarize in your own words the key ideas, and then see if you can use your newfound knowledge to solve these problems down at the bottom of the page.